So in this question, we've got a graph, so we'll do our Oizerga. Our origin is right here. We see going along the x-axis, 0.2, 0.2, 0.2, 0.2, 0. So this is our origin there. Our y-axis is velocity in normal units, and x-axis is time. So any questions about velocity and time, we'll read off the graph. The slope is delta v over delta t, which is the acceleration, and the area is v delta t, which is the displacement, delta x. We can see there are two graphs. So we have this one that's traveling at constant velocity, and then it slows down to a new speed, all the while heading in with positive velocity. This one is heading in this direction, and it slows down and comes to a stop, reverses direction to the positive direction, and ends up traveling at the same speed as the other one. So we have object X traveling a horizontal surface and collides with object Y. The velocity for each is shown, both before, during, and after. Both objects have a mass of 2 kilograms. Which of the following describes the momentum P of the system and the kinetic energy of the system? So let's just first get a handle of what's going on here. We know that momentum should be conserved. So P0, we have the mass of X. We have the momentum of X plus the momentum of Y. Collides with object Y. Doesn't say what happens afterward. And so they're asking about the whole system. So it's kind of unknown what happens here. What we know is they have the same velocity, which implies they stick together. It's implied stick together. So then afterward, we'd have the momentum of xy. So they both have a mass of 2 kilograms. So x has an initial velocity of 4, and y has an initial velocity of -2. And then we have a mass of 4 times its new velocity, which we are told is 1. So here we have 8 minus 4 equals 4. So check. We show the momentum before and afterward being conserved. So let's go on and see what they might be looking here for the choices. The momentum is conserved. True, true, not true, not true, because of the not conserved. So the question of what is going on with the kinetic energy, well, since it's stuck together, we expect it to not be conserved. This is a sticky collision, so we don't expect it to be conserved. Now, we can test it out. It'll be lengthy, but we should do it. So does our initial kinetic energy equal the final kinetic energy? So we have the kinetic energy of X plus the kinetic energy of Y plus the kinetic energy of XY. So we have 1/2 of 2, and the velocity of the X is 4 squared. And for Y, we have 1/2 2, and the velocity is -2 squared. And afterward, we have them stuck together, so there's a 1/2 of mass of 4, and the velocity is 1 squared. So the 1/2 of 2, we're left with 16. 1/2 of 2, we're left with 4. Does that equal 2? And the answer is no. 20 does not equal 2. And of course, we didn't expect that the kinetic energy would be the same, but that's how we can also prove that B is the correct answer.